Okay, I think I finally figured this recording thing out too. It said to stop the recording, you have to press stop in the toolbar. It's up in the corner and it's stop, but it has a circle around it, so it was confusing me. Anyway, explain how you know that triangle HIJ is an isosceles triangle. Can the measure of angle J be determined if the measure of angle H is 74 degrees? If yes, find the measure of angle J. Well, yeah, we can because we know that the sum of the interior angles of a triangle has to equal 180. So all of them together are going to equal 180 degrees. Angle H up here is 74 degrees. Wish I would use a different color for that 180. So this one's 74 degrees. We don't know what these two are, so we can call them x. And we can set up an equation now because we know that x plus 74 is going to equal 180 degrees. If we combine our like terms, subtract 74 from both sides, divide both sides by 2, and x equals 53. So the measure of angle J is 53 degrees. You can check this work to make sure it's right by 53 plus 53 plus 74 equals 180. And it does. You can just type that into your calculator. You don't have to do anything fancy with it. Determine if side lengths can be a triangle. This one is the stuff that we just learned with the triangle inequalities from module 7.3. That's one where I showed you the Professor Berger video. So you have to do the triangle inequalities theorem where you add each side and figure out if it's greater than the third side. So I'm going to do this first one in purple. This isn't really purple. I don't know what this is. Mauve. It's a weird word. So 4 plus 4, something, 7. Yes, it's greater than 7. So then 4 plus 7 is greater than 4. 7 plus 4, well, that's also greater than 4. So this one works. 2, 9, and 12. So the two sides and the third side. Well, 2 plus 9 is 11, and that's less than 12. So once you have a no, you can stop. You can just say no. 3 plus 5, something, 8. Well, 3 plus 5 is 8, so that equals 8. This is the example that Professor Berger talked about. If you put the two sides down on top of the third, it would make a straight line. So there's no room for you to add angle or add any pitch to those sides to make it work as a triangle. So it can't be equal. It has to be greater. Equal doesn't work. All right, the last set. 10 plus 12 is greater than 15. 12 plus 15, well, we know that's greater than 10. 15 plus 10, we also know is greater than 12. So this one does work. So you have two that work with greater than, one that's less than, and one that's equal to. Only the ones that have all three greater than would work. Okay, this is also from 7.3 that we just talked about. So you have triangle WXY, and it gives you the three angle measures, and it says which side has the least measure. You want to look for the angle that has the least measure itself, and it's going to be the side that goes with the triangle. So here is our smallest angle. I had to double check. 40 degrees. We talked about in class when we were doing the notes that the sides and angles are like the missing letters. So you have triangle WXY. They give you angle W. So the missing letters are X and Y. that has to be the side that goes with it. If you don't know for sure, you can sketch it. That's the good thing about geometry, is that most of the time you can sketch this out and you can say W, X, Y. It doesn't have to be pretty. This is 40, X is 60, and Y is 80. Well, we already determined that this was the smallest side, or angle measurement, so the side that goes with this angle is across from it, and that's XY. But if you can think of it as just the missing letters, you don't have to do the sketching. If that missing letter thing doesn't make sense to you, do the sketch. Do what's easiest for you. Okay, this is a homework problem, a former homework problem. Identify a sequence of rigid motions that maps one side of triangle ABC onto one side of triangle DEF. The sides must be corresponding. You must create the points of rotation, vectors, and etc. So the first sentence was the directions. I added the other stuff because I wanted you to recognize that you have to come up with this stuff on your own. Now, I'm looking for a straight edge around here. So I'm going to use the wrapper to this box of pens that I just opened. Okay, so there are several different ways to do it. On the answer key in your homework, I did it a different way. The first thing I'm going to do is translate this triangle onto the other. I want to get some points touching. So A, B, C needs to go to D, E, F. So you want to get some of these points together. Well, I can see that B can go to E, A could go to D, or C could go to F. But to me, the one that makes the most sense is taking B to E. It's the shortest distance. So this first one, I'm trying to stay color coordinated for you guys. I don't know if it's helping. Feel free to comment when you guys are done using this. So the first rigid motion, again, those are transformations that don't change size or shape. We can translate along B, E. We drew this vector. This little symbol means vector. So we created this. So now, after you, if you want to kind of like try to visualize this, I'll sketch this. This would be after the first movement. You would have this triangle here. And here's your sides. We want this side marked with the 2 to touch this side, ED and AB. This is side AB. It's like you took this and just slid it down. So the next thing you're going to want to do that's just going to make it easy is to rotate this around point E. You're rotating this side up. So then they will be touching. So rotate about point E until AB coincides with DE. You could shorten this. You could just say rotate about point E until AB touches DE. That would work too. You could translate from A to D and then rotate around. There's a lot of different ways that you can go about this, but I think this is the most efficient. All right, another one. This is really weird talking to myself, but if it's helping, then I'll do it on more occasions than just this. So this wants you to find X, Y, and Z. If you can't see this as 2 big triangles and 1 small triangle, then this problem is going to be really difficult for you. So the first triangle that you can look at is this one that I'm drawing in orange. And I'll roughly sketch it out here to the side, where you would have 60 degrees, 100 degrees, and x degrees. We know that the triangle has to add up to 180 degrees. So you just have to figure out the angle that's missing here. Well, 180 minus 100 minus 60 is 20 degrees. Oops, I'm going off the screen, sorry. X equals 20 degrees. Now, I love this problem. I've loved it since the first time I saw it in a book. That was my husband laughing behind me if you didn't hear him. Because he knows I'm a nerd. The second triangle has 3 angles where you have y degrees, 55 degrees, and 80 degrees. So to find y, you have to do 180 minus 80 minus 55 equals, well, that's 145 degrees. So y is going to equal 45 degrees. So we have now these 2 angles here, but we're still missing z. This is the part that people don't see. Well, a lot of it, they can't separate. You got to think about separating these things. If we're talking about this little triangle in the middle, sketches are not drawn to scale. So we had z degrees at the top. Y is down here, and it's 45 degrees. And this one is 20 degrees. This is where X was if you look at the picture above, and we pulled out this blue triangle and put it down here. So if you do, you're doing the same steps that you're going to take 180 degrees, subtract 20, subtract 45, and you're going to get the measure of Z. So Z is going to be 115 degrees. This was one of your homework problems. I don't remember which section it was in, but I know some people asked about it, and you have to be able to, again, see that as pulling these 2 apart and then recognizing that this middle triangle takes pieces from both to get your final answer. One more page, and they're just